Hello everyone, welcome to the channel Physics Fun. So we are continuing the properties of matter Pathfinder solution series. Okay, so let us read the question and then we will understand the concepts involved, and after that we'll discuss the solution. Okay, so the question is that consider a real fluid, compressibility of which is beta, and density at atmospheric pressure P naught is rho naught, right? So what is the difference? क्या मतलब क्या अलग है इस question में बाकी question से? Okay. So first let us see that what they are asking. So A is express density rho of real fluid as a function of depth h, right? And then we have to find out pressure as a function of depth h in a real fluid that is open to atmosphere. Fine. तो बस इतना ही सही डिफरेंस है कि प्रेशर का फॉर्मूला हमें ऑलरेडी मालूम है, द फेमस फॉर्मूला दैट इज P equal to P naught plus rho gh. बट एक कंडीशन है, हम लोग वाला फॉर्मूला यूज करते हैं एज्यूमिंग दैट लिक्विड इज इनकम्प्रेसिबल. मतलब इनकम्प्रेसिबल का मतलब क्या है? इसका मतलब ये है कि कितना भी बड़ा फोर्स और प्रेशर आप लिक्विड पे लगाओगे उसकी डेंसिटी चेंज नहीं होगी, राइट? अगेन विच इज अ वेरी गुड assumption फॉर लिक्विड्स बट वेरी बैड assumption फॉर गैसेस. ओके, क्योंकि आपको मालूम है कि कोई लिक्विड जैसे वाटर, कोई भी लिक्विड ले लो, ऑयल है ना, सपोज देयर इज अ लिक्विड इन अ कंटेनर, आप उस पर एक पिस्टन रख के उसका उस पर कितना भी प्रेशर लगाओ उसका वॉल्यूम बहुत ज्यादा चेंज नहीं होने वाला है, राइट? बट इफ यू टेक सम गैस, उस पर थोड़ा सा फोर्स लगाओ, थोड़ा सा प्रेशर लगाओगे, उसका वॉल्यूम हो सकता है हाफ हो जाए, राइट? 50% चेंज हो जाए, 100% चेंज हो जाए, 200% चेंज हो जाए. ओके, सो व्हाट इज द डिफरेंस इन दिस क्वेश्चन? इस क्वेश्चन में क्या है कि फ्लूइड है, उसका कंप्रेसिबिलिटी हमें दे रखा है बीटा. ओके, मतलब उसका डेंसिटी दैट फ्लूइड इज कंप्रेसिबल, उसका डेंसिटी प्रेशर के साथ चेंज होगा. सो वी कांट यूज P equal to P naught plus rho gh formula, है ना? Let us see how do we go about it. चलो, let us first see the concepts which I'm going to use in this. So let us say this is a ball, right? On this ball, if I apply an extra pressure P, right? Extra pressure, okay, very very important. Extra pressure मतलब एक बॉल है और आपने उसको, you are compressing the ball from all the sides, right? All these are very important words. Then its fractional change in volume is proportional to extra pressure, right? We know this. There's the formula. B is bulk modulus, which is negative of P. P is extra pressure, right? Delta V by V. Delta V is this, right? The gap which you are seeing is this. Change. Why is this minus sign? Because here volume will reduce. That is why there is a minus sign. This is initial volume, change in volume. B is bulk modulus. What is compressibility? Compressibility is inverse of bulk modulus. So beta here is 1 upon B. Right? चलो solutions पर आ जाता है. Solution पर आ जाता है. So I have copied the question again here so that it's easy for you to understand. चलो डायग्राम आपको दिख रहा है. यहाँ पर प्रेशर है P नॉट और यहाँ पर डेंसिटी है रो नॉट. नाउ डेफिनेटली जैसे जैसे आप नीचे जाओगे क्या होगा? डेंसिटी बढ़ेगी, राइट? क्योंकि प्रेशर बढ़ेगा तो डेंसिटी बढ़ेगी, है ना? तो ये चीज आप समझ सकते हो. किसी भी if you have a ball, right? Imagine a ball. If you compress it from all the side, mass remains constant, but volume उसका घट गया, है ना? तो डेंसिटी उसकी बढ़ गई. चलो कैसे इसको अप्रोच करें? देखो, इसको अप्रोच करने का सिंपल सा तरीका ये है कि आप हमेशा एक सिंपलर प्रॉब्लम को सोचो, राइट? सिंपलर प्रॉब्लम क्या है? Obvious है P equal to P when density remains constant. How do we find P equal to P naught plus rho gh formula? We can take this thing now, or you can take one liquid element and write the force equation, correct? So this is the liquid. It has density rho. If it is incompressible, density rho is not going to change. And if we take one element in this, then weight of this dmg is weight of this red part which you are seeing, right? And so let us say if area of this is beaker container is A, then what will be the equation? Iska free body diagram kya hoga? Free body diagram is, see, P plus dP, this force is acting upward into area of force, right? Ye pressure hai. P into A is acting downward. DMG is acting downward, right? Since this is an equilibrium, the total upward force is total downward force, है ना? बस सीधा सीधा लिख देते हैं. So what is net force upward? dp into a, right? dp into area. Area क्या है? Area इसका क्रॉस सेक्शन एरिया जो आपको दिख नहीं रहा है ना? ये बीकर है, इसका कुछ ऐसा एरिया है, करेक्ट? इट्स अ क्यूबॉइड. This is equal to dmg. What is dmg? dmg is density into volume of this part. What is volume of this part? Volume of this part is ADH. So A dH into G, right? So area cancels and we get dP is equal to rho G dH. Fine. Now, if density is constant, integrate kar denge, rho comes out, G comes out, P minus P naught is equal to rho GH you are getting. But here density is not constant. Okay. But you get the idea how to start. अब कैसे इसको स्टार्ट करेंगे? कंप्रेसिबिलिटी दे रखी है, राइट? तो आई एम नाउ गोइंग टू राइट दिस फॉर्मूला दैट, और बिफोर दैट, दिस इज फर्स्ट स्टेप. नाउ सेकंड स्टेप, बिफोर दैट व्हाट वी विल डू, वी विल राइट, or let us first write the formula of bulk modulus. Bulk modulus is equal to minus delta P. Delta P is the extra pressure, right? There I have written P, यहाँ पर मैं delta P लिख रहा हूँ, तो कंफ्यूज नहीं होना है. delta V by V, right? So from here, delta V by V is equal to minus delta P divided by V. Okay, B here is bulk modulus, not the compressibility. Compressibility is beta, right? Even I'm going to use this also later. B is equal to 1 upon beta. Fine. Okay. Now, see, in this dP is equal to rho. What is the problem? क्या इसको directly क्यों नहीं integrate कर पा रहे हैं? क्योंकि rho we don't know, right? Rho is not constant. तो हमें rho का variation ढूंढना है ना? In terms of compressibility. So for that now, I'm going to use another relation, जो कि एकदम आसान सा relation है. Rho is equal to m by v. Density is equal to mass by volume, right? If I differentiate this, d rho is now equal to 1 upon x. Differentiation is minus 1 upon x square into dv, right? Now from this equation and this equation, I can write that d rho is equal to d rho by rho. एक step में skip कर रहा हूँ, minus dv by v, right? This everyone understands. Okay. How do I write this? D rho is m by v को मैंने फिर से rho लिखा. So m by v is rho that comes here. D rho by rho is equal to minus dv by v, right? Now after that, you can pause this here and you can solve it by yourself also, right? There's nothing left, only maths. Fine. So what I'm going to do now, delta v by v, which is dv by v, for a small change we can write, we can now substitute this as this thing here, okay? So this becomes now d rho by rho is equal to, even this minus sign will go off, right? This is then equal to minus, sorry, minus will become plus dp by b, okay? 1 upon b is compressibility. So I can even write this as beta times dp. Okay, so d rho by rho, this is dp, this is d rho. Fine. After this, what I'm going to do now, density we have to find first, okay? So dp I'm going to substitute in terms of, sorry, here dp by b, yeah, correct. So this dp I'm going to write in terms of d rho. Fine. You can again, now after this point, you can do it by yourself also. Okay, so after this I'm now writing here. चलो भाई, dp क्या है? dp है d rho by beta. Okay, compressibility into rho is equal to rho g dh, which is now equal to d rho by rho square. Understood? Rho square. This is equal to now beta g dh. Now we can integrate from rho naught here 0, right? How do I know? From which part we know, which section of the question tells this limit? It says that density at atmospheric pressure is rho naught, okay? So when h is 0, density is rho naught, and at h height, density is rho. Right? So after that, just little bit more calculation. So that calculation I will skip and directly write the answer here. So you can just integrate this. 1 upon rho square will be minus 1 upon rho. Put the limits. You are going to get this. Rho is equal to rho naught divided by 1 minus rho naught beta GH. Okay. So now if normally what happens for the liquids, compressibility is very, very small. So if compressibility is very small, we can take the binomial approximation and write this as, you don't need to take binomial approximation, you can write the answer as it is. Since in the book answer is given in this form, so that is why I'm taking the binomial approximation. I'm writing 1 plus x to the power n approximately as 1 plus nx, right? This is binomial approximation. So rho naught 1 plus rho naught beta GH. This is our first answer. Right? I hope you understand this. Okay. Now after this, you can do the second part by yourself. You have to find out pressure as a function of depth h in the real fluid that is open to atmosphere. So dP is this. Now rho we know. So in this equation now, we are going to substitute rho as a function of h. So just for completion, I will do second part also. So dP is now equal to rho is rho naught 1 plus rho naught beta GH G and TH, right? So if we integrate this, it becomes then P naught to P and 0 to H, right? So what do we get now? We get P minus P naught is equal to rho naught G comes out. Here you get 1H plus here you get rho naught beta G H square by 2, right? So that is the second answer. So second answer I will now write P is equal to P naught plus rho naught G H. I'm taking H also common. So H 1 plus rho naught beta G H by 2. So that's the second answer. This is our first answer and this is the second answer. Right? So I hope you understand. This is again a moderate question, not very difficult. Okay, so if you have found my explanation good, if you have understood, then you can like this video and subscribe the channel. You can also share this video with your friends, right? Thank you very much. We'll now. So tomorrow I will come back with next question. Thank you, everyone. Thanks for watching.